So this is 2025 paper 1 question 5, and we're basically given a quadratic here, and we're told to complete the square on it here. So I think the easiest way to do this, given the way that they phrase the question, is since g of x, we want g of x to be equal to both of these things, we can just let these two things equal to each other. Now, of course, there is a method for completing the square that you can do if you'd like, but I think this is a little more straightforward. So we want this quadratic to be equal to a times x plus h, the whole thing squared, plus k. And now if we simplify both sides and compare them, we can figure out what a, h, and k are. So the first observation you can make is that a is probably going to be equal to 5. Don't worry if you didn't notice that, but this is just kind of, I suppose, mathematically thinking, because there's a 5 in front of the x squared, and when we multiply out this bracket, we're going to get an x squared, and that should be multiplied by a 5. So let's keep that in the back of our minds, but if you didn't spot that, that's okay, because you'll figure it out anyway, as you'll see here. So when you multiply out the bracket, you get x squared plus 2xh plus h squared, then we get plus k, and then we can just multiply the a in, and we get ax squared plus 2ahx plus h squared a plus k. So the reason I've written it like that is because now we can compare the two sides together. So we have 5x squared plus 20x minus 12. So we know that the number in front of the x squared should clearly be a 5, and the number in front of the x squared here is an a. So that means clearly that a is equal to 5. So then we can look at the number in front of the x should be a plus 20, and the number in front of the x on this side is 2ah. So that means we can say that 20 is equal to 2ah. Okay, and then we can just solve. So we know a is 5, so 20 will be equal to 2 times 5 is 10, h, which means that h is equal to 2 when you divide both sides by 10. And then finally, the constant term. So on the right-hand side, the constant term is this bit, because there's no x's or anything in it. And on the left side, the constant term is minus 12. So that means that minus 12 should be equal to h squared a plus k. And then we can just sub in what we know. So we have minus 12 equals, so h squared is going to be 2 squared multiplied by a, which is 5, plus k. So 2 squared times 5 is 4 by 5, which is 20. Bring it to the other side, you'll get minus 32 equals k. And that's it. So we can write g of x in that following form. So we can say g of x equals a, which is 5, times x plus h, which is x plus 2 squared. And then we have plus k, and k is minus 32, so we're just going to have minus 32. And that is our answer. So in the next part, we're told to simplify this expression here using the laws of logs. So you might want to go to the formulae and tables booklet to page 21, which is where the indices and log rules are. And we can use those to simplify it. So the first thing that I would notice is that, as you can see, there's a 5 in the power of everything inside the log. So we can bring that power to the front as per this rule. And it's important that this power is on everything inside the log. So see, it's x to the power of q, and x is the thing inside the log. You can see that power of 5 here is on the entire thing inside the log, so that's why we can do that. So ln of e cubed p to the power of 5. We can write that as 5ln, and then we'll have e cubed p. We want it in the form c plus d ln p. So we can also split up this because we have two things multiplied together inside the log. So if you have a look up here in the top right, you can see when we have two things multiplied together inside a log, we can add the two logs separately. So we'll have 5, and this 5 is going to be multiplied by everything because we're only changing the log part, right? The 5 is not changing at all. So that we're going to get ln of e cubed plus ln p. And then what we get is we get ln of e cubed is going to be, well, ln and e kind of cancel each other out, and that's also in the tables book. So ln means log base e. So as you can see, log base a of a to the power of x is just x. That's just because they're inverse functions of each other, if you understand that. So you'll basically just get 3 out from that, and then we have plus ln p. And then finally, they want it in the form c plus d ln p, so we can just multiply out the brackets again, and we get 15 plus 5 ln p. And that is correct, because we have c plus d, and c and d are integers, and we have ln p, so yeah, that's good. Also, if you wanted, you could have actually done it a different way. You could have actually just multiplied out the powers. So, you know, one of the indice rules is that you can, if you have two things multiplied together and they're to the power of something, you can put the power on each of them individually. So you could write that as e to the 15 times p to the 5, and then when you simplify that, you get the same thing as down here. And then the next part, in part C, we're given simultaneous equations, and we're told that one of the solutions is on the y-axis. So if you think about one of the solutions being on the y-axis, let's say it's here. Well, what that means is that the x value is 0 if it's on the y-axis, and then we don't know what the y value is, it's y. So one of the solutions to the pair of the equations is on the y-axis. So let's call that solution 0, I don't know, we'll call it m, because we don't know what m is. And we know that that's one of the solutions, and we can sub that into both equations and see, then that might help us out. So we have 2x minus y, so that's going to be 2 times 0 is the x value, minus m is equal to 7. So that means that minus m is 7, so m is equal to minus 7. So we've already figured that out, so now we know one of the solutions to the equation. So if we know that 0 minus 7 is a solution to the equation, then we can actually just, we know what x and y are, so we can actually just sub x and y into the second equation and figure out what n is pretty quickly. So in the second equation, we're going to have 0 squared plus minus 7 plus 2 times minus 7 squared equals n. Because we know that's true, because we know that this is a solution, so we're able to sub those in, and we know this equation is true. Then we can just simplify it. So we have minus 7 plus 2 times positive 49, because minus 7 and the minus is also squared, so a minus squared gives us a positive, equals n. And then that'll give us 91 when you put it into your calculator. So n is equal to 91.